We are back. We are back with another Kaggle session. Uh, I guess I'm late today, so if you guys were waiting, sorry for that. I'll be more consistent from tomorrow. And if you can see, I hope I don't know why they did not did any update here to me, but it should be having something, right? Feb 13, I don't know why there is no activity, but I've been consistent, so never mind. Let's go. Where we should be going? Learn. Oh, before that, uh, clock 01 00 and start. Yeah. So we were doing intro to machine learning, and today we are going to see underfitting and overfitting. But before that, what we just studied that in this module, there is a decision tree, I guess, model that we used, and they explained that this is one of the most basic model that can be used in the machine learning. Um, so we'll start with the model called decision tree. That there are fancier models that give more accurate predictions, but the decision tree is easy to understand. They are the basic building blocks. All right, and then we will be this. Okay, we use data to decide how to break the houses into two groups, and then again to determine the predicted price in each group. The step of capturing pattern from data is called fitting or training the model. So basically, yeah, we use the dot fitting command in the scikit library that I remember from yesterday. So that we did. The data used to fit the model is called training data, and we the training data which we received, we split it into two halves. One we use for training and one we use for predicting. So improving the decision tree. Okay, the decision tree probably makes more sense because it captures easily rental with more the bedrooms and tend to sell higher prices than the okay. So basically there are decision trees. Yes, we did study that. Then I'll go back. Then there was kind of basic data exploration where we started with how to load CSV file. So we started with pandas. We gave the file. We read the CSV. We then just started describing it. It gives all the these are called features. So all the features values they started giving us, for examples, rooms. We have a total count of this much rooms, uh, right? And the price is kind of sum of all these rooms, kind of. Distance is also, I don't know what is the distance means, but these are number of records available, I guess, on this data sets. That is what we are describing, but let's confirm from Gemini what is the describe used. So wait, I know that the describe function is used to describe the data set, different properties, data sets features different properties from the above image. Of the one of the data set from Kaggle. I think ये data set किसका था? Yeah, Melbourne housing snapshot. Can you help me to understand why the count value is not same for all of the features, and what can I conclude from the above describe of the data set, or just simply teach me what are the or just simply teach me what I can conclude from the describe on a data set. It's a great observation. When you are looking at a summary table like this, the count row is often the first place where the data starts telling a story. This here is a breakdown for those who differs and what are the rest of the table is trying to tell us. What is the count value different? In pandas, the describe function counts only non-null valid values. If the count or for more column is lower than the other, it means the column has missing data. Looking okay, room price distance is all having 3580 entries. This is likely the total number of rows in your data sets. However, car only has 13518. So right. And building area. Hmm. So have some more features uh, description as well. Hmm. As you notice with the car column, the count row tells us exactly where the information is missing. Count rows, building area, car built, nearly half are missing. Year built, this is okay, only conclusion. This is a huge red flag of that for a data scientist. If you want to use a building area to predict prices, you will have to figure it out how to handle the fact that 40%, 47% of the houses don't have the measurement listed. Spotting outliers and errors. Looking at the minimum and max values helps you to see if the data is realistic. Year built in is 1196 unless there is a medieval castle in Melbourne. This is likely typo in the data says perhaps it was meant to be 1996 or 1996. The max is 2018, which makes sense for a more modern snapshot. Building area, the max is 45 compared to that mean of 151 houses. That is 300 times larger than the average. Is either a massive commercial complex or a data entry error. Land size, the max is understanding the geographical spread. The latitude columns gives the physical boundaries of your data sets, means the logging. Since the standard deviation is very small. Hmm. I did not get from the house price um, information. Got it. All right. So basically, we studied this, then we started interpreting the data, including the value and sorting order, and we interpreted the data. Right. Your first machine learning. I think I was not commenting on all those things. That why it happened. Selecting data for modeling. Your data set has too many variables. Okay, now we started selecting the data. So basically, for selecting what we did, that to choose variables, we will need to see a list of columns in the data sets. Okay, that is done. Hmm. Your dataset has too many variables to wrap your head around or evenly print out nicely. Um, how can you pare down this overwhelming amount of data to something you can understand? So we will start by picking up a few variables using our intuitions. Later courses will show you statistical techniques to automatically prioritize variables. Okay, so basically that basically we started looking on the columns in the data frame. So basically we define a data frame, uh, and then we read the file, we print the columns. By this we got all the columns, right? We got all the columns, and then we dropped. There are so many ways to subset. Okay, we dropped it. Okay, the Melbourne data has some missing values. We will learn how to handle missing values later. Your IOR data doesn't have missing value in this column. To you doesn't have any missing values in the column you use. So we will take the simplest option for now, or drop houses from your data. Mm, don't worry about this one. Okay, so basically there are many ways to select a subset of your pandas course. In the we'll cover this in depth. Okay, so basically dot notation is this one, and the prediction is this one. Selecting a pool on the dot notation. Okay, basically selecting the prediction target. Okay, we selected the prediction target, and which is basically what we want to predict, and that we took it from one of the columns. So this is our data frame which we defined, and from there we are predicting this column. And then we selected few features, choosing features. Okay, the columns that are inputted into our models are called features. In our case, those would be the columns used to determine the home prices. Sometimes you will use all columns except. Okay, so this is what we did. um, X equals to Melbourne data, Melbourne features. Okay, X dot. So basically X is basically what we are deciding. X is what the data is called X. Okay, by convention this data is called X. Okay, here we selecting, providing a list of columns inside the brackets each item. Okay, for now we build a model with only few. Okay, so now we are building a model, and for model building we selected this we selected this we selected this columns, and from there we started describing it, and we used x dot head. Okay, to be why usually checking. Okay, building your models, then we use scikit-learn, and scikit-learn library to create your model. When coding, this library is written on sklearn. So we basically define the model, then cap provided the data, and then predicted the value, determine how accurate the model is. sklearn import decision tree regression, Melbourne decision tree regression, Melbourne effect. We did this, and there is a concept of random state. Many machine learning allows some randomness in the model training. Specifying a number of random steps ensure that you get the same result in each run. This is considered a good practice. So basically I have to do it because random state is basically they are doing something randomly, and by defining it, it would be random, but our result after each run will be same. We know you have fitted a model that we can use to make predictions. In practice, you want to make predictions for new houses coming on the market. So now how he did is making predictions on the houses X head. Melbourne property prices. It's already 3 minutes have passed. Melbourne model property predictions. So they did the predictions. Now X dot head. Now they printed the X dot head, which is the model. So they defined the head, and now what they did is X dot head. So this predicted, and this they predicted. So this is how they did model validation. So they just help in model validation. In validation means a train test split on and calculating the mean absolute error. So basically error we calculated by actual minus predicted. So we calculate the mean and we were getting the mean somewhere around this 434 when we did on a lot of the values. Now coding it, when we started coding we got this values. So basically when splitting we got a higher difference. uh, hmm. Now the concept is under who is this man? Dan B. Kagel, founder of Decision.ai. Competition, datasets, code. Um, Okay, so now let's start underfitting and overfitting. At the end of this step, you will understand the concept of underfitting and overfitting, and you will be able to apply these these ideas to make your models more accurate. Okay, so this is basically some concept which can help us to make the model, which can help us in improving the model accuracy. Experimenting with different models. Now that you have a reliable way to measure model accuracy, you can experiment with alternative models, and now you can see which gives best predictions. But what alternatives do you have for models? You can see in the scikit-learn's documentation, okay, that the decision tree model has many options, more than you want or need for a long time. The most important options determines the tree's depth. The most important option determine the tree depth. Recall from the first lesson in this course that tree depth is a measure of how many splits it make before coming to a prediction. There is a relevant shallow. This is a relevantly shallow tree. Okay, so what we did was, in practice, it's not uncommon for a tree to have 10 splits between the top level all houses and a leaf. As the tree gets deeper, the data sets get scaled up to the leaves with fewer houses. If a tree only had one split, it divides the group into two groups. If each group is split again, we could say we get four groups of houses. Splitting each of these again would give us eight groups. If we keep doubling the numbers of adding and to the power 10, then we will be having 10 to the power 1024 leaves. When we divide the houses amongst many leaves, we also have fewer houses in each leaves. Leaves with very few houses will make the predictions that's quite close to the home's actual values, but they may make very unreliable predictions for the new data sets because each prediction is based on a few leaves. That's correct. That's correct. When all the data is divided 10 times, so we will be ending up at a very, the houses ending up in the last level of leaves will be very less, and they kind of used to predict in that leaf, which is not small. This is a phenomena called, okay, this is a phenomena called overfitting, where a model matches the training data almost perfectly but does poorly in validations and other new data. Okay, on the flip side, if we make the tree shallow, it does gives up the houses into very distinct group. At an extreme, if a tree divides the houses into two or four, each group still have a wide variety of houses. Resulting predictions may be far off more most houses even in the training data, and it will be bad in validation too for the same reasons. When a model fails to capture important distinctions and patterns in the data, so it performs poorly even in the training data. That is called underfitting. Since we care about the accuracy on new data which we estimate from validation our validation data, we want to find the sweet spot between underfitting and overfitting, which we want the low point of the red and validations curves in the figure below. Got it. So basically I have to overfitting. Okay, give me a summary of underfitting and overfitting. Since you are dividing into Melbourne housing data, underfitting and overfitting is crucial. Since of the Goldilocks problems of the machine learning, you don't want a model that is too simple or too complex, but you want that is just right. Underfitting too simple model. Underfitting occurs when your model is too basic to capture the underlying trends in the data. Imagine trying to predict 9 million Melbourne mentions using only the number of car spots. It's not enough information. The symptoms high error on both the training data and the new data. The cause the model has a high biases, it makes it small assumptions that aren't true. All three bedroom houses. Overfitting two complex models. Okay, overfitting happens when your model matches the training data too perfectly. It starts memorizing the noise, random fluctuations instead of the actual patterns. If your model memorizes that a house on a specific street with exactly 3.5 bathroom and blue doors sold for 1.2 million, it struggles when it gives a similar house with the red colors. The symptoms very low on training data, uh, but very high on the new test data. The model has high variance. It's too sensitive to small changes in the data sets. So use more data. Okay, I understand, but bro, give me definition of the underfitting and overfitting so that I can explain it to a kid of age 5. Let's say देखते हैं क्या बताता है. Underfitting the lazy learners. Imagine I want to tell you to draw a cat, but how you only draw circles. But you only know draw a circle. The problem, you are too lazy or simple. You didn't pay attention to the ears. You the tail. Predicting the house prices using only the color of the front door. It's too simple. It does not help. Underfitting. Memorizing the that houses are. Now give me a simple definition of the underfitting and overfitting. Of course, when a model is too simple to learn the underlying structure of the data, what they mean is too simple. Isn't too simple a kind of relative term? You hit the nail on the head. Too simple is absolutely a relative term in machinery. It's always measured against the complex to the truth you're trying to predict. Think of it as trying to define a complex movie plot using the only 3 words. It's too simple because the story has way more layers than these words can hold. Okay, so basically underfitting, if I can conclude, is that underfitting is kind of a model where we haven't trained that much and it's very simple. It just kind of understanding one of few features and it's trying to make predictions based on that. But the overfitting is something that uh, it trained so heavily on the training data that it came close to a point where it's actually learned all the data and the trends, and this has kind of impacted the uh, so it's kind of memorized all the data. It's come to that point, but using the same model to predict on a trained data, it fails because it actually learn the data but not learn the pattern or to do the prediction. Right. Okay. So basically, our goal is to find a sweet spot between the overfitting and the underfitting. So this is the result. Okay, so mean absolute errors and the validation. This is a good graph. Okay, there are fundamental alternatives for controlling the tree depth, and many allow for some routes through the tree to have greater depth than other route. But the max leaf node argument provides a very sensible way to control overfitting versus underfitting. The more leaves we allow the model to make, the more we move from the underfitting area in the above graph to the overfitting area. Underfitting to overfitting. Oh, perfectly, yeah. Scikit-learn. So basically, what we did is from the scikit-learn metrics, we imported the mean absolute error. Scikit.tree, we imported the regression. So get MAEE, max leaf node, train X, val Y. These are the model decision tree, and this is the function we define. Get MAE, mean absolute error. So to get mean absolute error with max leaf nodes, this train X, validation Y, train Y, validation Y. So model we pass the model to the decision tree function, and then we use the model to train it based on the when we did train X, train val Y, these things, and these can come from these split train and split function. This can came from train and split function. All these values, if we can divide it into 2 to a half, then we did then model validations, mean absolute and return. Okay, the data is loaded into train X, val Y, train Y, and val Y in the code you have already seen. Okay, the data is loaded. So basically, they define the path, they read the path, they loaded they remove the missed value, then they choose the target feature, then they kind of selected the features on which they want build the model, and then they define the model here, loaded into the X, and then they use the split to split it here. And what they did is that they use this thing to provide max leave node and the okay, so basically we are improving the max leave node from 550 to 5000, and mean absolute error, which is we define the max leave nodes and the value it returned. So max leave node and the, so basically this is for each 50, what is okay, so this is here. Of the option listed, 500 is the optimal number of leaves. 500 is the optimal number of the leaves. Conclusions. Here is the takeaway. Models can suffer from either overfitting or underfitting, capturing spurious pattern that won't recur in the future, leading to less accurate predictions, or underfitting, validating or capture relevant patterns, again leading to less accurate predictions. Okay, now optimize the models you have built. Let's see. Okay, so basically I have to run this by default. Come on. Okay, this is gonna run by default. The recap is kind of, I loaded the data from here, I read the CSV, I select the target object, I created the data set and the model on which I created the model, and then I use the train test to split train x and val x, then train y and value y, validation for y. Uh, what we did is that we used the decision tree, then we created the model using the decision tree, we fit it, and the model is ready. Now when the model is ready, we did the value prediction is iowa model.predict.val x. Validation prediction we did is we predicted on val x. Val x is this. So when we use it, predicted val mean is I don't know, train x or train y. What was that? Train x and train y. Train x and train y. Your model validation, your first machine learning is Smith. Model validation. Okay. So basically, we use the coding it. The scikit level has a function called to break up the data in two pieces. We will use some of the data as training data to fit the model, and other we use the data as validation data to calculate the mean absolute error. They would have explained this somewhere, right? No worries. I forgot that what is the use of train x, val y, and train this. So this should be here. Split the data into training and validation data for both the features and the target. Okay, the split is based on a random number generator supplying a numeric value. Okay, so decision tree regression, basically we have a lot of there's a decision tree classifier. Okay, so focus, I have 30 minutes left. Okay, now basically he has created, you could write the function get me yourself for now. We will supply this in the same function that you read in the previous lesson. Just run the cell below. Okay, so they did it for us. Run हो जा भाई, कुछ वैसे एग्जीक्यूट करना नहीं है, सिंपल. Step 1, compare different trees sizes. Write the loop to find. Okay, so loop लिखने का मेरे को आता है for how they defined that name. I just want to check that. How did they define the name uh, which they were looping? Is that max leaf node? Okay, so for max leaf nodes in candidate max leaf nodes, max leaf node. So basically क्या मेरे को प्रिंट करना था, that I have to print max leave node. Okay, I have to use get underscore MAE, which will be using max leaf nodes, and I will be passing it the train underscore x. This I will be passing. Okay, yeah, these all I will be passing. And then on top of it I am going to print these. So my MAE and best trees store the value of max leaf node, best tree size. But I have to print it first, right? It is not going to print because of the error. And for that I will pause it. क्या भाई मैं for loop गलत दिख रहा हूँ क्या? For max leave node. Spelling mistakes. Candidate max leave node is different. Okay, so the best value match is how can I decide the best value match? How can I decide the best value match? Print you must create the following max leave node. So basically these are in order. How can I decide? Because for me to decide which is having the best value, I need to know the actual price. You can get me in the loop. You need, okay, I know this, brother, but I just want to see scores is equals to left size. But why we are selecting the minimum? Why we selected this thing? I mean, I get this thing. Okay, so now basically what he's trying to say, because I got this time the number of node size, I can use that to here to fit the model. Hmm. Fill in argument to make an optimal size and comment. So what's the minimum score? Hundred. 100 is the minimum score, so they are saying that when I am gonna create this decision tree regressor, I need to use here 100. I hope it will take it, and then train underscore x comma train underscore y comma train underscore small x. That's how they write, right? Val x. Okay. Okay, I'll copy this thing. But they are using the. They said all data, so I just do not need to split it. Model dot fit uh, fit x. What's wrong? What's wrong? Check hint. Fit them with max leave node in the first step. Will you? Oh, okay, I have to define this. Max leaf node is equals to this, like how we do it, or is it like this? How we define it, man? Max leave node. Oh, max leave nodes. That is called max leave nodes equal to 0. And if I run, oh, okay, now it's the error, and I have to fit the model is I need to provide train x and train y, because we are running it on everything. Train x and validation, what we had for the y and okay, so x and x comma y. Correct. I mean, I did. I was just thinking that I don't know anything here, but that's it. That's what we did. To be honest, I have to practice this thing, because this is quite a lot of things that I need to memorize here. But no worries. Let me go to the next topic, which is Or do I have to submit the competition? I mean, I have to submit it as well, right? That's how it's gonna just show me on my profile that, yo, on my profile that I am doing some work. I have not submit anything. Anyhow, so we have 18 minutes left, and using more sophisticated machine learning, which is random forest. Let's study this. Introduction. Decision tree leaves us with a difficult decision. A deep tree with a lot of leaves will overfit because each prediction is coming from historical data from only the few houses at its leaf. But a shallow leaf tree with leaves will perform poorly because it fails to capture the many distinctions in the neural data. Even today, most sophisticated modeling techniques face these tensions between underfitting and overfitting, but many models have clever ideas that can idea to better perform. We will look at the random forest as an example. The random forest uses many trees and it makes predictions by averaging the predictions of each component tree. In general, generally has much better prediction accuracy than a single decision tree, and it works well with default parameters. If you keep modeling, you can learn that the models with better performance, but many of these are sensitive to of getting the right parameter. Okay, if you keep modeling, you will learn that models with a better performance, but many of those are sensitive to getting the right parameters. Examples: you have already seen that the code to load a data in a few lines. At the end, data loading is equals to we have the following variables: train x, train validation y, train y, and validation y. Okay. Mm, you already seen that the code has the following data as a few times. At the end of the data loading, we will have something with train x val by train y. Okay, so basically we just splitted. We load the file, we read the file, we drop the missing values, we selected the target, uh, we selected the target, then we selected the features on which our model is going to get trained, and then we loaded that model in x, and then we are using to split it, and it split it between x and y. So so basically we the whole model with this data set, and that the price targets are kind of selected between train x val y, train x and val. This is confusing what they did this. Hmm. Can you help me in understanding the last split, like train underscore x, train val underscore small x, that line. In machine learning, train and test split data is one of the most important steps that you will take in the final setting up your models. Here is the breakdown that specific line is doing and why it's necessary. What is it doing? When you run this thing, you taking your big pile of data and cutting into two separate piles: training set train X and train Y. The state data model looks at to learn the sees both features and accurate actual price to find. And the validation set this data is not is the this is the data the model is not allowed to see during the training. We hide the price. Hmm. एक्सरसाइज सक्सेसफुल था यार, तो मेरा यहाँ पे कुछ अपडेट हुआ भाई? ये अपडेट क्यों नहीं हो रहा है? Anyhow, okay. So basically, we build a random forest model similarly how we build the decision tree in the scikit, this time using the random forest regressor class instead of the decision tree regressor. From ensemble import regressor forest model is equals to random forest regressor random state 1 forest model filled train x and train y. Melbourne prediction is equals to for predict value x, val x, predict val x. Okay, print mean absolute value is from the Melbourne predictions and the validations y, and this is what we got. Okay, so basically when we split it in train x and validation, so we split it on train x and train y, and then we used validation x to predict, and whatever the value we got val y, we compared it with the Melbourne prediction. Okay, so I got it. So basically we splitted the data. So basically we selected the x and the y, and the train x is basically the whole data set, some part of the whole data set, and train and validation x is validation x is the see these shit, like they have written it in this way, it's confusing. So we use train x and train y to train the model, and then we provide x to predict, and whatever value we'll get, we'll compare it with value y to find the mean thing. They should have written in more other way, right? But yeah, that's kind of confusing. Conclusion: this is likely room for further improvement, but this is a big improvement over the best decision tree of 25,000. There are which parameter which allow you to change the performance of the random forces, which as we use the maximum depth. There is a likely room for further improvement, but this is a big improvement over the decision tree of 25,000. There are parameters which allow you to change the performance of the random forest much as we change the maximum depth of the single decision tree, but one of the best feature of random forest model is that they generally work reasonably even without tuning. Your turn. Let's start exercise. Okay. Let's see. So basically I know I have to run this, and here RF model, define the model, set random state to 1. So they have imported everything, decision tree regressor. Okay, RF model is basically random forest regressor with a target. Let's state equal to 1. Fit your model में fit your model fit your model में क्या करते हैं? Okay, rf underscore model is equals to um, okay, fit no is equals to model dot fit, and I will be using train x and train x and train underscore y, and I will then, for validation, what I need to calculate is rf model dot predict on val x, predict on val x. So जो भी आएगा वो मेरा val v होगा, and then मेरे को निकालना है mean absolute error, mean absolute error on the value which I received here. So basically मैं इसको भी ऐसे भी लिख सकता हूँ that कैसे उसने डिफाइन किया था, that model validation val prediction is equals to rf model this rf model dot predict val x, and then I have to use this thing val predictions comma val underscore y, and hopefully it will oh my god, it's the random state, not target state, random state, and val prediction is equals to predict predict how they predict these things, fit Iowa model dot predict what, that's what I did, right? So val prediction is this rf model dot fit train x train y, and then val prediction is equals to Iowa model, which is I use rf model to fit, and they used to predict on x. Why they used to predict on x? Okay, predict on val underscore x, correct. Validation for random forest. Oh, I'm left with 6 minutes, so yes, it's done. Let me just try to submit it, hopefully. Oh, now they are saying I am ready for machine learning competition. Wow. Did they submit it? I don't know that if I will be able to do it or not. मतलब कैसे submit कैसे करें भाई इसको मैं. Anyhow, machine learning competition. Machine learning competitions learned today. Okay, machine learning competitions are a great way to improve your data science skills and measure the progress. In the next exercise, you will create and submit prediction the housing. Okay, okay. In the next housing, okay. Now here I'll be using getting started prediction competitions. So submit prediction. Here I will be learning great way to improve your data science skills. Okay, the next is you will create and submit predictions. So basically, your turn. What you have learned in the course: create a submission to a Kaggle. Create a submission to a Kaggle. How can I submit? Okay, I guess it's not a tutorial. It's the same thing on. It's the same last thing where at the end I have to machine learning company where I have to submit things. All right, they're not going to teach us how to submit thing. I have to learn this. So basically, looking at the columns list and okay, what's next? There's mentioned about some of the features will throw an error, and if you try to use them to train your the interactive mode, machine courses will teach you to how to handle these errors and the features. Okay, you will also learn to use XG booster technique, giving enter better accuracy with the end. The Pandas course will give you the data manipulation skills to quickly go from conceptual ideas to implement in your data science project. So basically, I know, and you are also ready for the deep learning course where you will build models with better than a human level performance at computer vision task. Okay, so basically I got to know that in tomorrow's Kaggle session I will be going with the pandas first, and then I'll be going with the deep learning. But starting tomorrow's session, I'll more gonna have I need to submit this thing. I was trying to submit, but it's just not getting submitted. Your profile, it's not getting submitted. No worries, no worries. I will do it later. But let me open the pandas course and the deep learning course. Okay, so here is the pandas course, 4 hours estimated, and then there is a deep learning, deep neural network, stochastic gradient descent, overfitting, underfitting, dropout, and batch normalization, binary classifications, detecting the Higgs with portions with TPUs. All right, all right. I guess yeah. I am ready for tomorrow's streams. It was a good one. I finished my. Uh, I finished the machine learning beginner course, and I got to know what exactly what we are doing in the machine learning. Mm, the more takeaways is that I know all the models are already implemented in the scikit-learn, but I need to understand what's the math was behind those models. So basically, so whatever models I have read so far, one of them is the decision tree regression, and now I'm starting with the random forest regression. So basically, I have to understand the math behind it. So probably tomorrow I'll be doing that, and yeah, that's it for now. I will be ending the stream exactly on 1 hour.